નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study the question number 4 of exercise 6.4. This is the topic of standard 10 chapter number 6 triangles. So what is the question? The question is, if the areas of two similar triangles are equal, prove that they are congruent. So here we have given that the area of the two similar triangles are equal. Then we have to prove that the two triangles are congruent. So let us suppose two triangles. One is the triangle ABC, second one is triangle DEF. So here we have given that the two triangles are similar to each other. Second thing we have given is that their areas are equal. So we know that the theorem we have studied, that is related to the areas and the sides of the triangle. So according to that theorem, if the two triangles are similar, then we can write down that area of triangle ABC upon area of triangle DEF. This we can write down as AB upon DE whole square. In the same way, BC upon EF whole square, that is equals to AC upon DF whole square. Right? This is the equalities. This is the ratio of the square of the sides, and that is equals to the ratio of the areas of the two similar triangles. This we can write down according to the theorem number 6.6. Right? Now, one more thing we have given is that the areas of both the triangles are equal. That means whatever the area is of ABC, that is equal to area of triangle DEF. So the same things are there in the numerator and the denominator. So when we cut both the same things, we get 1 here, right? So this right hand side will remain as it is, that is 1 is equals to AB upon DE whole square, that will become equal to BC upon EF whole square, and that is again equal to the AC upon BF whole square. Now what we have to prove? We have to prove that the two triangles are congruent to each other. We have one criteria of the congruent, that is side. That means if all the three sides of one triangle is equal to the corresponding side of the another triangle, then the two triangles will become congruent. So see, one by one now we can compare this ratio AB upon DE whole square with 1. Then we compare this ratio with 1. Then we compare this ratio with the 1. So when we compare this ratio with this, what will we get? We get 1 is equals to AB upon DE whole square. Now see, when we take the square root both the side, we get 1 is equals to AB upon DE. And when we take the DE to the left hand side, therefore we get DE is equals to AB. So see, in these two triangles, one of the side, that is DE, is now equal to AB. So similarly, when we compare this with the one, similarly, what we get? Similarly, if we compare this ratio with this, in this way, we will get here EF is equals to BC, and we get DF is equals to AC. Right? When we compare one by one this ratio with this one, we get EF upon BC. When we compare this with the one, we get DF is equals to AC. So in this two triangle, if the three sides are same, equal, all the three sides are equal, then we can say that this triangle ABC is congruent to triangle DEF by side 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 rule or side 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 criteria. So this is how we can prove these two triangles congruent to each other. Right? Now let us study the question number 5. The question is DEF are respectively the midpoints of side AB, BC and CA of triangle ABC. Find the ratio of the areas of the triangle DEF and triangle ABC. Here we have one of the triangles ABC. D is the midpoint of side AB, E is the midpoint of side BC and F is the midpoint of side AC. So two triangles we have to consider, DEF and ABC. And again we have to find out the ratio of triangle DEF to area of triangle ABC. Both the ratio of the areas of both the triangles, that we have to find out. Okay, so whatever we have studied in this chapter, we know that if we can prove these two triangles DEF and ABC similar, then according to the theorem 6.6 we can write down their ratio according to their sides, right? There is a relation between the area and the side. So here we know that we have to prove this triangle ABC and DEF as a similar. So how we can do this? See, here we have given that D and F are the midpoints of the side AB and BC, right? So let us start from there. D and F are midpoints of sides AB and AC, right? So remember the midpoint theorem that we have studied in standard 9, that if we join the midpoints of the two sides of a triangle, then whatever the line segment we get will be parallel to the third side. So according to the midpoint theorem, here we can write down that according to the midpoint theorem, we can write down that DF is parallel to BC. DF is parallel to BC. Right? So now DF and BC will become parallel to each other. In the same way, if we are considering E as a midpoint of BC and F as a midpoint of AC, then we can say that EF is also parallel to AB. So in the same way, using midpoint theorem, we can also write down that EF is again parallel to AB. Okay, here one more thing we can write down, DF parallel to BC. One more thing we are used to write in standard 9, that DF, what will become DF? DF will become 1/2 of BC, right? Remember this result that we are writing while we are using the midpoint theorem. Give it equation number 1. Okay, now see, here we have write down that DF is parallel to BC. Now instead of BC we can write down B, that is DF is parallel to BE. Why? Because B, E and C are collinear. So instead of writing BC we can write down BE. In the same way, here also we have write down that EF is parallel to AB. So instead of that we can write down that EF is parallel to DB. So because A, B and D, all the 3 points are collinear, we can write down that DB instead of AB. Now notice BEFD. In this quadrilateral, DF is parallel to BE and EF is parallel to DB. That means both pair of opposite sides are parallel to each other, and therefore we can write down that BEFD is a parallelogram. Right? This is the property of the parallelogram. So as Now BEFD is a parallelogram. According to the property of parallelogram, opposite sides of the parallelograms are equal. So here we can write down that angle B will become equal to angle F, right? B and F. This angle and this angle will become equal, right? So this is why, because opposite angles, right? Opposite angles, and opposite angles of a parallelograms are equal. So see, as we have proved that BEFD is a parallelogram, in the same way, similarly, what we can prove that? We can also prove that ADEF is a parallelogram. ADEF is a parallelogram, right? Similarly, also we can prove that ADEF is a parallelogram. So when it will become ADEF is a parallelogram, this angle A will become equal to angle E. That is, angle A will become equal to angle E. Again, the reason is opposite sides of the parallelogram. Okay. In the same way, again we can prove that DECF, right? DECF is a parallelogram. So again their opposite angles, that is angle number angle C and angle D, both will become equal. Angle C and angle D, both will become equal. So if we can give it the equation number 2, okay, give it equation number 2, because 1 is already there. Give it equation number 3, give it equation number 4. So see, in equation number 2, 3 and 4, angle B is equals to F, angle A is equals to E, and angle C is equals to D. That means all the three angles of triangle ABC are equal to all the three angles of triangle EFD. So we can write down that triangle ABC is similar, triangle ABC is similar to triangle. See, what we have to write down here is EFD, right? Because angle A is equals to angle E, B is equals to F, and C is equals to D. So now, as we have proved that the two triangles are similar according to the angle rule, now that we have to find out the ratio of both these triangles. So now we can write down according to the theorem 6.6 that area of ABC upon area of EFD, that is equals to the square of the corresponding side. So here we are taking the BC side and here we are taking the DF side or FD side, and it is the square. Now here we have to use equation number 1, that is EF instead of DF. We can write down, if we take the DF to the left hand side, what we can write down here is that D, okay, here we require BC upon FD. So we will make the BC as it is, taking DF to the denominator. What will remain here is 2 upon 1, that is, by taking this 2 to the left hand side, 2 upon 1. So the same thing here we have to apply, that is 2 upon 1 square. And what is 2 square? 2 square is 4 and 1 square is 1. That is, we find the ratio of the area of triangle ABC to the area of EFD. We can write down that, we can state it as the area of ABC is 4 times the area of triangle EFD. So this is how we can prove, how we can find out the ratio of these two triangles. Okay, so this is all about this lecture. Thank you.
Thank you for joining us.